Assalamu alaikum students. I hope that you all are fine. In this video lecture I am going to discuss about alkene and some methods that we mostly use for the preparation of alkenes. What are alkenes? Alkenes are the hydrocarbons in which any two carbon atom may have double bond. So we can say that these are unsaturated hydrocarbon. Unsaturated hydrocarbons. Any two carbon atoms may have sp2 hybridization, and its general formula is Cn. General formula is CnH2n, where n is the number of carbon atoms. Number of carbon atoms. Its simplest and first example is ethene. In this, one carbon is attached with other carbon through double bond, and each carbon has two hydrogen atoms. It's ethene. Now I am going to discuss some preparation methods of alkene. First method is dehydrohalogenation of alkyl halide. Dehydrohalogenation of alkyl halide. Alkyl halide. Just focus on the terms that's giving us main idea about the reaction. D means removal. It means removal. Hydro stands for hydrogen and halogen stands for X atom that may be equal to fluorine, chlorine, bromine, iodine. Now combining these terms, that it is the removal of hydrogen halide. It is the removal of hydrogen halide. From what? It is the removal of hydrogen halide from alkyl halide. Alkyl is R group and halide is halogen. These are actually alkyl halide. We are removing XX or hydrogen halide from alkyl halide. It is the removal of HX from alkyl halide. And this process is done with the help of any base, that may be OH, potassium hydroxide or sodium hydroxide. Catalyst that we use in this process is actually base, and that may be potassium hydroxide, sodium hydroxide, and so on. Now going toward the reaction, carbon, single bond carbon, halogen. Here is hydrogen, 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 and here is again hydrogen. It's ethyl halide, and we are using catalyst any base OH negative. In case of alkyl halide, beta hydrogen is mostly acidic, and here is the alpha carbon, it's alpha carbon and it's beta carbon, and the hydrogen attached with beta carbon is beta hydrogen, and it is mostly acidic. Base has ability to pick acidic protons, so it will attack on this hydrogen, and these electrons will come in between carbon and carbon, and these electrons will go toward halogen, forming double bond. In this reaction, water will form, halogen will be removed as a halide ion, and double bond will form in between carbon atoms. And we know that it's alkene. It is alkene. After this, hydrogen halide will be removed and hydroxyl as a catalyst will be regenerated. The next method of preparation is dehydration of alcohol. Dehydration of alcohol. Dehydration of alcohol. Again, focus on the terms. It's giving us idea about the reaction. D means removal. Hydration, it means water. So we can say that it's the removal of water. From what? It is the removal of water from alcohols. Removal of water from alcohols. We use in this process sulfuric acid, phosphoric acid, phosphorus oxide, etc. Any of them can be used as a dehydrating agent. Dehydrating agent. These can be used to remove water from alcohols. The ease of removal of water from alcohol is in this order. We can easily remove water from tertiary alcohol, then secondary alcohols, and the most difficult removal of water is from primary alcohols. It is the ease of water removal. Here is the main reaction of dehydration. It's ethanol, this bond will come toward the bond of carbon atoms, and this hydroxyl will leave and pick this hydrogen, forming water molecule. It's alkene. I think these two methods are very clear. Now I am moving towards dehalogenation of vicinal dihalide. Dehalogenation of vicinal dihalides. The third step of preparation of alkenes is the removal of halogen from vicinal dihalide, and this reaction is named as dehalogenation of vicinal dihalides. Dehalogenation of vicinal dihalide. Again focus on the terms. D means removal. D means removal. Halogen. We are removing halogen. From what? We are removing halogen from dihalides. Which type of dihalides? It's vicinal dihalides. There is two types of dihalides. First is geminal and second is vicinal. In case of geminal, halogen atoms are attached with the same carbon atom. And in case of vicinal dihalides, halogen atoms are attached with adjacent carbon atoms. Like this. Here is one halogen and second is here. It's vicinal dihalide. But in case of geminal, both halogen will attach with one carbon atom. They will attach with same carbon atom. We can define it as it is the removal of halogen atoms from vicinal dihalide. Vicinal dihalides. In this case, we use Z and zinc in the presence of alcohol. This reaction can easily be carried out with the help of alcohols. Here is vicinal dihalide. I am using chlorine. In the place of halogen, Zn will react with vicinal dihalide in the presence of methanol, and it will form ZnCl2, zinc chloride, and forming an alkene. That's ethene. You can write it as, for your ease, ZnCl2, and here will be the formation of double bond for the preparation of alkene. Next method of preparation of alkene is Kolbe's electrolytic method. We have already discussed about Kolbe's electrolytic method for the preparation of alkene. Kolbe's electrolytic method for the preparation of alkene. Electrolytic method. In this, we use a beaker or cell in which we add sodium salt of dicarboxylic acid. Sodium salt of dicarboxylic acid. It's sodium salt of dicarboxylic acid. Then we apply electric current on this solution. Here is positive electrode and here is the negative electrode, and we use a battery. As we know that salt will ionize in the solution and will form a positive ion and negative ion. The negative ion will be attracted toward anode and positive ion will be attracted toward cathode. In this we use sodium salt of dicarboxylic acid and we forms its solution and apply electric current. We do actually electrolysis of this salt, forms a solution and apply electric current. There will be two types of reactions in this cell. First reaction is on anode and second reaction will be on cathode. In solution there will be solution like this: CH2, CH2, carbon double bond oxygen, carbon double bond oxygen. Here is oxygen and sodium, oxygen and sodium. It will ionize in the solution and will form two sodium ion, two Na positive and one dicarboxylic ion, O negative, and carbon double bond oxygen O negative. Now what will happen at anode? At anode we know that anode has positive charge, so this negative charge carrying ion will go toward anode. CH2 single bond CH2, carbon double bond oxygen O negative, carbon double bond oxygen and O negative. At anode it will lose two electrons. It will lose two electrons and will form radical CH2 single bond carbon double bond oxygen O radical, CH2 single bond carbon double bond oxygen and O radical. In next case there is a removal of carbon dioxide, one electron from here and one electron from here, here and one electron from here, and this electron will come toward here, this will here. Again this radical have one electron, so this electron will move toward carbon and oxygen. The bond carrying two electrons, carbon carbon, one electron will come toward here forming double bond, and one electron will come toward these two carbon atoms forming here is the double bond. Two molecules of carbon dioxide will remove. Two molecules of carbon dioxide will remove, and there will be the formation of alkene, that's ethene. At cathode what will happen? At cathode water molecule will be break up into hydrogen and hydroxyl, and this hydroxyl will combine with sodium, form sodium hydroxide, NaOH, sodium hydroxide. I think this step is confusing to all of you. I am going to clarify it again here. Just try to understand. Again writing this: CH2 single bond CH2, carbon double bond oxygen, carbon double bond oxygen, and O negative, O negative. When this ion go toward anode, it gives its 2 electron to anode, forming a radical. Now this radical is reactive. Here are 2 electrons. Here is also 2 electrons. This electron will come toward here, and this electron will come toward here. This will form carbon dioxide. Here is remaining 1 electron. In this case, this electron again come toward here, and this electron will be here, forming again carbon dioxide. This electron will come here, and this will come here, forming double bond. So in this case, we can say that 2 carbon dioxide molecule will be removed, and here will be double bond among these 2 carbon atoms, forming alkene. At anode, oxygen will lose 1 electron, and due to loss of 1 electron, it will form radical, and this radical is reactive, and in that case, it will convert into carbon dioxide involving alkohol functional group, and will remove carbon dioxide, forming alkene. Next, final preparation method is partial hydrogenation of alkynes. Partial hydrogenations of alkyne. Partial hydrogenation alkynes. We know that alkynes has triple bond, and when we add hydrogen molecule in alkyne, it will convert into double bond and will form alkene. This process is done in the presence of platinum or nickel. Here is alkyne. When we add hydrogen molecule, it will convert into alkene, and this process is done in the presence of nickel catalyst. Double bond carbon, hydrogen, and hydrogen. I hope that these all methods are clear to you, and if you have any question regarding preparation of alkene or alkene, you people may ask. Thank you, and please subscribe my channel, share my videos to others. Many students can take benefit of my videos. Thank you, and Allah Hafiz.